All right, I hope you all are doing well out there, and welcome to my channel. I do educational videos on a wide variety of topics, although I've pretty much been focused in on one topic for the last year, which is the reciprocal system of theory. And today is video number 353 that we've done on Dewey B. Larson's reciprocal system of theory. And Larson lived from 1898 until 1990. Was born in North Dakota, moved out to the Portland area, and did most of his work out there. Eventually, he has kind of an organization out in Salt Lake City as well. Larson's basic idea is that we live in a universe made out of motion. The universe is not made out of matter. It's not made out of energy, but is made out of motion. And for Larson, motion was the relationship between space and time. This posits a reciprocal relationship between space and time, hence the reciprocal system of theory. And time and space do not have any independent existence. They only exist together in motion, mainly as a fraction. Motion is a fraction with time or space as the numerator and space or time as the denominator. But space and time can come in different different gradations or measurements, different powers. And so there are a lot of different permutations of time and space, or space and time. And they constitute all of our basic scientific units, such as speed, space over time; energy, time over space; acceleration, space over time to the second power; matter, time to the third power over space to the third power; and so on and so forth. And basically, the universe is made out of motion. Motion is the relationship between space and time. And space and time both have their coordinate aspects, meaning that they can come in 3 dimensions. They both have their clock aspects, meaning that they both come in what Larson calls their scalar aspect. When Larson says the universe is made out of motion, he's referring specifically to a kind of motion that he calls scalar motion. That is a motion that is recognized by legacy science, but not given any type of significance. The way that you would visualize scalar motion is using a balloon with dots on it. When you blow up the balloon, all of the dots are moving away from each other, but they're not moving in any specific direction. You can really think of it as they're moving in all directions. That is the characteristic of the scalar motion. It's a motion that has a magnitude but has no specific direction. And it is this kind of motion that this universe is constructed out of. Now, this was also observed by the astronomers in that all of the distant galaxies are moving away from each other. And it can be observed in the inverse, in gravity, when you take that balloon and you suck it in, and all of the dots begin to move toward each other. This is analogous to gravity, and the only way that you actually get a gravitational field or a direction is when you assign one of the dots as the reference point. So the direction is coming from the reference point, not from the scalar motion. once you assign a reference point, once you say this particular dot is not moving, then all of a sudden, all of the directions become defined. And you can say that each particular dot is moving in a specific direction. And it appears as if there's a field between one dot and another dot, or between the reference point and another dot. It appears as if one is being drawn to the other, but that's not what's actually going on. What's actually going on is all of the points are being drawn toward all of the other points. So, this concept of a gravitational field as well as a magnetic field or electric field are fictions that are related to the assignment of a reference point. Now, space and time also come in only discrete units, meaning that there is a minimum unit of space and a minimum unit of time. You have to have a full unit before you have anything. And if you have one full unit of space in one full unit of time, then you have the speed of light. The speed of light is what Larson refers to as unit speed. 1/1 = 1. And this is basically the one place where space and time are equal to each other. And so this is the midpoint of this universe, or Larson calls it the null point, or the reference point, the natural reference system. The state of rest of this universe is moving outward at the speed of light in all directions. And then from there, we break into two separate sectors of the universe from that boundary. So this unit speed is a boundary between two reciprocal sectors of the universe. Larson calls these the material sector, which is where the motion is slower than the speed of light, and the cosmic sector, where the motion is faster than the speed of light. And these are reciprocals. So if you can figure out what's going on in the material sector, which the legacy scientists have mapped out, then you can also understand what's going on in the cosmic sector. Only you have to invert the roles of space and time. So in the material sector, you have coordinate space, 3 dimensions of space, and clock time. The time is always getting later and later and later and later. It's a scalar motion in time. In the cosmic sector, you have coordinate time, 3 dimensions of time, and you have clock space. Space is always getting farther and farther and farther apart. Scalar motion in space. So that kind of maps it out a little bit. That's basically outlining Larson's first fundamental postulate out of 2. And his second fundamental postulate is more or less that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, one person who has come along and has kind of disagreed with that second postulate is Dr. Bruce Peret, who is one of the principal revisers of the reciprocal system and has come up with what he calls RS2, reciprocal system 2, the re-evaluation of the reciprocal system that he arrived at along with Dr. KVK Nehru. And Dr. Peret would rephrase that second postulate to say that the universe conforms to the relations of ordinary mathematics, getting rid of the word commutative. Its magnitudes are absolute, getting rid of primary magnitudes. And its geometry is projective. Now, projective geometry is a more encompassing geometry than Euclidean. Euclidean geometry is a subset of projective geometry. Now, what's interesting about this, and we went through this a couple weeks ago with one of Peret's papers, is that when Peret adjusts his second postulate in that way, he obviates the need for all of the metaphysical postulates that Larson has to come up with. Larson has 4 metaphysical postulates in addition to his 2 fundamental physical postulates. And, so this is, he came up with the 2 physical postulates first, but then when he attempted to delve into metaphysical matters beyond the physical, such as life and consciousness and ethics, he found that his 2 postulates did not do the job. His 2 postulates did not cover those areas. And so he proposed 4 separate postulates for his metaphysical study, which is his final book called Beyond Space and Time, that actually came out after he died. And by adjusting the second postulate in the way that Peret did, he no longer needs those 4 metaphysical postulates, and he's able to use just the 2 fundamental postulates of Larson's amended to cover the metaphysical sector as well, which is, I think, a great accomplishment. Now, we are looking at another paper that Bruce Peret wrote called Dimensions and Displacements. And we started that paper yesterday. This is paper RS2-106. He's got 9 separate little tutorial papers on the reciprocal system 2, the reevaluation of the reciprocal system. So this is number 6. We've gone through the first 5 in earlier episodes, and then we started this one in yesterday's episode. So if you want to go to the top, you want to check out at least the tail end of yesterday's video. Okay, so now today we're starting with a section that is called Number of Dimensions. And just to point out, before we got to this point in this paper, he was talking about kind of the orientation of scalar motion. So when you have motion being a relationship between space and time, then you have like really 3 different scalar orientations, even though he doesn't use that word here. They can either be, space and time can be equal to each other, which is the natural reference system and the state of rest of the universe, and it is the speed of light outward in all directions. 1 over 1 equals 1, unit speed. That's where space and time are equal. Or space could be greater than time, or time can be greater than space. When time is greater than space, you're talking about material sector phenomena. When space is greater than time, you're talking about cosmic sector phenomena. So now we're going into, and as I mentioned, there is a difference between dimensions of space and dimensions of motion, of scalar motion. It requires 3 dimensions of space to define 1 dimension of scalar motion. And we only can really properly view 1 dimension of scalar motion at a time in the reference system. there are two other scalar dimensions that we can only incompletely view, or view a part of, or indirectly view. I believe he's going to get into that here. So, okay, number of dimensions. Now that we have this tri-state dimension of motion, you know, greater than, less than, or equal to, how many of these dimensions can be linked together to form a single compound structure? Professor KVK Nehru, in his paper, Some Thoughts on Spin, addresses this question as a problem in geometric stability. If you have orthogonal dimensions, how many can exist together in a stable form? His answer is just probability of arrangement. In a closed group of operators like 1, I, J, and K, the three imaginary operators, the result of the combination of any number of basal elements is also a member of the same group. The result of any such combination can be known only if all the possible binary combinations of the elements are first defined in terms of the basal elements I, J, and K themselves, besides, of course, the identity operator 1. Let there be n basal elements, excluding the unit operator 1, in a group. Then the number of unique binary combinations of these elements in which no element occurs twice is n times the quantity n minus 1 all over 2. We can readily see that a group becomes self-sufficient or finite only if the number of binary combinations of the basal elements is equal to the number of those basal elements themselves. That is, n times the quantity n minus 1 over 2 equals n. And that equation is only solved by the number 3. The only definite solution for n is 3. 0 and infinity are other solutions. Therefore, if we regard space or time as a group of orthogonal rotations, its dimensionality has to be 3 in order to make it self-sufficient dimensionally. Otherwise, the number of dimensions either has to shrink to 0 or proliferate to infinity. Now, I can kind of understand that line of thinking, but I don't know that why do you have to regard space and time as a group of orthogonal rotations? I don't necessarily see that they have to be orthogonal means at a right angle to each other. If we regard space and time as a group of orthogonal rotations, its dimensionality has to be 3. Who says that they have to be orthogonal? I just continue to think of Buckminster Fuller's tetrahedral coordinates, and you know, there you have 4 coordinates. They're not orthogonal, but I believe that they are still independent. I could be wrong. Perhaps somebody knows that better than I do, but it seems to me like the tetrahedral coordinates are self-sufficient, and that they create a coherent structure without having to be orthogonal to each other. What is the magic about orthogonality. Okay, Nehru's analysis indicates the point of dimensional stability is 3 dimensions, and all of the building blocks of the reciprocal system are based on 3 dimensions of motion. 3 scalar dimensions, evenly distributed across the material and cosmic sectors. Each dimension has 3 states, with the states of speed and energy constituting some kind of structure. Now remember, speed is a material sector thing, energy is a cosmic sector thing, and then in between them is the speed of light, or I guess you could also call it the energy of light. So these 3 states, greater than, less than, or equal to, or really greater than, equal to, or less than, constituting some kind of structure. Larson refers to these offsets from the state of unity as units of motion, where each dimension of motion has 2 units of motion, s over t and t over s. So you start from the state, the natural reference system, the speed of light, 1 over 1, and in one direction you go toward s over t, and in the other direction you go toward t over s. Now, this section is called dimensions of motion. Though there are 6 units of motion, numbered 1 through 6 on the diagram that you can't see, you will never see Larson refer to more than 3 of these units. When the 4th unit of motion is reached, the net motion is no longer speed, but now energy, making the structure cosmic in nature. So the 4th unit of material motion, looking at the table left to right, is analogous to the 3rd unit of cosmic motion, looking at the table right to left. So basically, you know, you have the boundary in between, which is the speed of light. On this side, you have the 1st, 2nd, and 3rd dimensions of speed on the lower material sector half. And over here, you have the 1st, 2nd, and 3rd dimensions of energy. If you're going into that 4th dimension of speed, you are actually in the 3rd dimension of energy, and vice versa. So let's read that paragraph, that sentence again. So the 4th unit of material motion, looking at the table left to right, is analogous to the 3rd unit of cosmic motion, looking at the table right to left. And the motion is no longer directly observable with our conventional instrumentation. Any aggregate will have its net motion in one of these 3 units of motion, which Larson refers to as speed ranges. We got the 1 minus x region or range. 1 minus x, that's the speed of light minus x, which is the low speed range, 1st unit. This is the realm of conventional science and what we observe as our spatial reality. But then we have the 2 minus x range, that an x being less than, as x is a fraction, so 2 minus a fraction less than 1. So basically it's saying that the speed is between 1 and 2 units, 2 minus x. Whereas 1 minus x is saying it's between 0 and 1 unit. So the 2 minus x range is intermediate speed, the 2nd unit. These motions are observable but have inverse properties, such as white dwarf stars, and inverse thermal motion, super hot appearing cold. Now, a white dwarf star is basically a star that has exploded like a supernova, but the explosion has been so powerful that some of the star is blown past the speed of light. And then when it goes past the speed of light, it moves from this low speed range into the intermediate speed range, and then you start dealing with these, what he calls inverse properties. So when something is blowing up in space, it expands like this. That's a supernova. But when it blows up in space, when it blows up beyond the speed of light, the explosion is no longer in space, but it is in time. And when it blows up in time, we don't see time. We only see space. And so the way that we see time is that we see the reciprocal aspect in space. And so if something is blowing up in time, that means it's expanding in time. But we don't see time, we only see space. So we see it as imploding in space. And that is a white dwarf star. That is a star that's extremely small and extremely dense because it is imploding. It's getting smaller and smaller. The same amount of mass is being confined to a smaller and smaller area of equivalent space. That's what it's called, equivalent space. It's not in space, it's in equivalent space, which is the inverse of being in time. So the explosion goes into time. Okay, and then the 3 minus x range is what Larson calls the ultra high speed range, the third unit. Also observable as an intermediate speed motion, but which is the 2 minus x range, but with more pronounced effects, such as the anti-gravity motion of pulsars. Due to the dimensional reduction at this speed range, ultra-high speed motion tends to be linear. The dimensional reduction, yes, you only see things in one, you only are able to actually see one of the 3 dimensions there. So this is a stellar explosion that is occurring, that is going more than twice the speed of light. When it gets into that third region, then you see even more pronounced effects. In addition to the white dwarfing that's going on, you start to see what would be called a pulsar, which is kind of a turning off and on of the star. Larson goes over all this in his book Universe of Motion, and also his book Quasars and Pulsars. We will eventually get around to looking at those, I believe. Now Peret is kind of introducing this stuff kind of out of nowhere, and so it's difficult to follow, I recognize. But that's an important concept in the reciprocal system, is the 3 speed ranges. Now, the only time you're really dealing with these 3 speed ranges in Larson's reciprocal system is when you're dealing with stars and galaxies, astronomical effects. That's really the only way that he's documenting that you can blow past the speed of light, is through a powerful explosion. Now, Peret tends to use these speed ranges more broadly, and he'll probably get into that. But I believe we're going to stop right there in the middle of this section, and start up again tomorrow. Oh, well, let me just read this last paragraph here of this section. Larson uses the 1 to x, 2 to x, or 3 to x, or 3 minus x, 1 minus x, 2 minus x, 3 minus x format to indicate which unit of motion the speed is in. For example, 2 minus x says that the motion is in the second unit of motion at some value less than the maximum for the unit, which is 2 units. Okay, now the next section coming up is called the concept of the clock. And so we're going to be dealing with scalar, his discussion on scalar motion with the clock. Okay, if you feel like you're lost, don't fret. You know, that happens from time to time with the reciprocal system. It's a lot of mental gymnastics, a lot of unfamiliar mental processes, and a lot of unfamiliar territory that you have to cross into. Just let it wash over you. Don't judge it. Just take it in, and once you have a fuller picture, then you can evaluate it for validity. But you can't reject it just based on the current knowledge that you have, because you're not seeing the full picture. And you know, it would be easy to reject these concepts based on the prior knowledge that you already have, but that is not really a valid way to look at it, because you're not you're using circular logic that way. Okay, well, thanks for tuning in.